So let's wait for maybe 1 more minute, then we can start. Okay, I think we are good to start. Is my screen visible?
Yes.
Yes.
Okay. And I will also paste the GitHub link and also the today's slide. Maybe you can use it if you see any delay in presenting, or you can use it for your future reference as well. Any questions from the last session so that we can discuss them before we get started?
Yeah. Yeah, hi Lavanya, this is Suchayita. So I have a little confusion between the cluster and the context thing. So yeah.
Okay. Yeah, we can discuss them. That's fine. Maybe at the end of the session, we can discuss what's the cluster, what's the context, we can also visualize what's kube config. Yeah. Maybe when we connect between the clusters today, we can use that to clear them. Yeah.
Okay.
Good, so that you have deep dived into it and came up with the question. So without any delay, let's get started. So before starting the session, I'm going to ask few questions. So if somebody who is interested, they can unmute themselves and then answer the question. Or I can call out the names if not, if no one is on it. Yeah. So last session we have seen about the master and worker node components. So the questions are related to them. So who is responsible for IP assignments or IP address management? So it's commonly called as IPAM, which is IP address management. So who is responsible for that? Any guess?
Kube Proxy.
Kube Proxy is the underlying agent, but who does that primarily? So there is maybe I can pull up the architecture slide.
CNI.
Exactly. So that's your CNI plugin. So CNI, it can use a it can have various components like Kube Proxy or eBPF technologies. So the main thing that is taking care of this IP address management is the CNI plugin. So what are the different CNI plugins? If you know anything already, just name it a few.
Calico, Cilium.
Yes. So widely used is Calico and Cilium. And in the kind cluster, we use a KindNet, which comes out of the box with the kind cluster. And there is something called as Planel, which is not a production-ready CNI plugin. So without CNI plugin, there is no networking. So you will have to have a different CNI plugin when you create the cluster. So you will have to define the CNIs so that this IP address management will be taken care of. Okay. So moving on to the next. Who handles the service networking? Service routing? So basically, who is responsible for traffic routing?
Service traffic is managed by Kube Proxy.
Exactly. So Kube Proxy is the one that manages your service level routing. So whenever you send any traffic, first it goes to the load balancer or ingress, whatever you have it in your front end, and then it sends the traffic to the service, and then service sends your traffic to the pods. So that's the flow. But we are going to deep dive into the traffic flow today. But behind the scenes, the service level networking is taken care by your Kube Proxy. Okay. And what happens when the scheduler is down?
The running pod stays alive, but the new scheduling doesn't happen.
Exactly. Yep. So scheduler is a master component that's responsible for scheduling your pod onto the node, available node. So based on the compute resource that it has. So if your scheduler is down, the existing pod will still run, but new pods will stuck in pending. So your cluster will still work when the scheduler is down for some time. So if all the pods are restarted, then again your cluster will be in down state. Okay, that's right. And when the Kube scheduler is down, what will be the state of your pod? If you are scheduling a new pod, what is the state that it will be in?
Pods go into pending.
Yes, exactly. So as long as the scheduler is up, it will be in pending state. And it's not only for the new pods. When there is a restart of the pod happens, again it will go in pending. Even for the existing pod, due to some scenario, if it gets restarted, then it will again go to pending state. Not only the new pods, the existing pod, whichever is restarting, that will also be not available. Okay. Yeah. So Kube Proxy has different algorithms inside it. Do you know what are them? Like what is the
Round robin?
Yes, that's an algorithm. I would say, like, what is the program that Kube Proxy runs? So basically it is IP tables or IPVS. So all these are programs that runs inside the Kube Proxy. You can choose either IP tables or IPVS rules to route the traffic. So these are different mechanisms within the Kube Proxy to route the traffic. Okay. So what happens when the controller is down? Yeah,
It will not maintain the desired state like replicas. So we'll be having different types of controllers to maintain different states. One for maintaining the replica state. So that will not be done.
Yes. So not only for the replicas, just adding on to your answer. So if controller stops working, then your node controller will be stopped working. So it cannot assign any new nodes if there is a demand. So node will not be spinned up or spinned down. So scale up and scale down of nodes will not happen because your node controller is down. So, and also the replica set controller, it cannot scale up and scale down. Last week we have seen that. So until this controller manager is up, your replicas will not be scaled up and down. So that's one thing. And even your deployment will not work when the deployment controller is down. And then job controller, if you are running a scheduled job, that will also not run. So there is no different controllers, but all together forms only single controller, the controller pod that is running in your Kube system namespace. So it has to be up. Otherwise, all the controllers will not work. So for cloud, do you know what controller specifically is needed?
Cloud controller.
Exactly. So for AWS, they will have a different cloud controller, and for Azure also they have a different set of algorithm for the cloud controller. So the reason behind this, it's responsible for adding the Azure or AWS VMs within the node. So the scaling happens with the cloud network. So it has to have a separate controller. So every cloud provider has their own controllers. So these are specifically for cloud providers. So those are also need to be up. But we are not managing those controllers. So those controllers are managed by the cloud providers themselves. So basically, what's the difference between the managed Kubernetes and the self-serviced Kubernetes? Any idea what would be the difference?
In self-managed, we control all the control planes, whereas in managed Kubernetes, all the control plane components are managed by cloud itself.
Yes. So in the managed control plane, do you think there will be a chance that these master node component goes down?
Yes, there are chances of ETCD nodes getting exhausted out. Yeah.
Okay, but this is, I'm talking about the cloud managed Kubernetes. In the managed Kubernetes as well, it will go down.
Yeah, if cloud goes down, like their service go down. Yes.
Okay, but that is not your day-to-day scenarios. Like
Yeah.
what cloud provider offers 99.9% based on your tier that you select, right? So probably even if it is down, you cannot do much on it because these master components, we don't have control. When it is in a managed Kubernetes, we don't manage any of these master components. We don't manage etcd, cloud controllers, schedulers, queue controllers. We can't even see them. So it's there in their own master planes. So we don't have access to the master itself. So with the managed Kubernetes, you don't need to manage the master component. When it is down, you can't do much about it. So basically, it cannot go down on your day-to-day basis because they offer 99.9% availability. So I have never seen, and in the 7 years, I have never seen a chance like master component goes down in managed Kubernetes. But wherein self-managed, we do manage the configurations, upgrades, we change it. So there are chances that that can go down. So that is why if you compare the self-managed and the cloud provider managed Kubernetes, the cost, there will be a cost, but the complexity is very much less in the cloud provider managed Kubernetes. Okay, so to answer to that question, the master components rarely, very, very rarely it goes down. Okay.
So in the production, we only use the one control plane or multiple?
In the production, when it comes to self-managed, we should not configure a single master node for running all of our master components. So you should have high availability strategy over there. You should have three etcd or 2 schedulers or 2 control planes. But still, if those 2 nodes are down, still your components will go down. Master component will go down, and you know the consequence of master components going down by now, right?
In the cloud?
So in cloud, we don't. So they manage the high availability themselves. So they manage multiple master nodes. So we don't have information like are they managing 3 or 5? Doesn't we are not bothered about it. As long as the master is up, we don't care about that. So behind the scenes, what they do, so they keep on switching the masters. So we don't know what's the master IP itself. So all that we need to have connectivity to the master IP, and that connectivity is established from your Kubernetes, from your subnet IP. So that IP is connecting to the master node. That's it. So behind the scenes, they can route it to different master nodes. So it's all a single API server, but it can have multiple masters, be it 5 or 10 or whatever. So they have those routing strategy to the master. So we don't even see them, and we don't know what the number of master components that they manage behind the scenes. Okay. Did that answer, Priyanshu? Yeah.
Yeah.
One question is there, ma'am, in chat box. Can you please pick that?
Check. How about ephemeral storage if it's self-managed? Yes. So ephemeral storage, here now you are talking about the empty directory, right? So on the host network. Is it right, Joe?
Yes, yes.
Yes, empty. So you should not, in a production grade environment, you should not have an empty directory. Empty directory means in a host, a specific volume will be created, and that volume is from the host. So if that node gets restarted for some reason, so you will lose the data that's there, right? So for stateless application, you can still have empty directory, but those will be lost when a VM is deallocated or VM is restarted. So you will lose the data. So for production grade application, we won't be using empty directory. Instead, what we do, we will use a disk. So we will use CSI drivers, and then we create a disk, and those disks will be attached to your VM. And when your VM is restarted or deallocated, it goes and attached to the another virtual machine. So you won't lose it if it is a disk, or sometimes you can configure Azure disk, Azure storage, and AWS disk, and in NFS. And there are a lot of disk in AWS. I'm not sure about the terminology, but the disks will be there in the cloud or in the self-managed also. You can have a separate disk and manage them. Okay, that answered your question, Joe?
Yeah, thanks. One point to get some clarity. So we have a disk where it gets accumulated every now and then, and we get alerts that the disk usage is high, and they keep increasing the disk. What would be the best practice, like if we need to manage this proactively? Any best practices?
Yes, this is a real production issue that we often face. So specifically, for example, if you are using a Prometheus and Grafana, that goes on whenever your metrics gets added. So the disk that you provision today is of 50 GB, it gets full by one day, right? And then you have to keep on increasing the volume size. You can resize the volume size, but that's not your solution, right? You cannot keep on increasing the volume size because of the cost, but rather than you have to see and check your application, you have to have some retention period to clean up the data in the disk. So basically, for example, in Prometheus, you have to clean up your data every 15 days or 30 days based on your company needs. So how long they want to retain the metrics, that's based on that you keep the data, and then the rest of the data you have to clear. So then only you can manage the disk size. Otherwise, it will be keep on growing. So you cannot manage them, and cost will be inevitably, it will be increasing. So you have to control the data that's there in the disk. So you have to have some cleanup mechanism. Did that answer your question, Joe? Okay. Good. Okay, so when the Kube Proxy is down, what happens to your kubelet? And what happens to your node? Any idea?
Pods will not communicate.
What happened to the existing pods?
They will work.
So when your Kube Proxy is down, that means your node will be down, right? Because it cannot update the data. So maybe the existing pods will work for some time, but when the your kubelet is down, means your node will go on as not ready state. So if node is in not ready state, did it respond to the API server with the right desired state, like what pods it has? So if it is down, if your Kube Proxy or kubelet is down, then your node will not be in healthy state. It will be down. Okay. So even your existing pods will not work as you expect. Okay, with that we can start. So today we I think my slide is visible, right?
Yes, yes.
Okay. So week 2, we are going to see more about the networking, Kubernetes networking, and also if possible, we will see about the etcd backup and restore today. Okay. So without further delay, the agenda is I think some of you have joined today, right? I think Indrajit, or do we have someone else join today? Is this your first class?
Chetan.
Okay, Shwetan and Ninja. So for you guys, we'll brush up with the last week's recap. So what we have seen, and then by now you would have got what we have discussed, right? So based on the questions. So we'll have a quick recap on the architecture, and then we'll discuss about the deployment, stateful set and DaemonSets. What's the difference and when to use what and what is what. So even in the client cluster, we can see what is DaemonSet and deployments and stateful set. Yeah. So that we are going to see, and complete traffic evaluation we are going to see evolution. So traffic flows, how the traffic flows from external world until inside the pod. So we are going to deep dive into the traffic flow. So we will visualize Kube Proxy today, how it is going to update, and then possibly we will see the Cilium CNI. So what's the difference between them, and what is the advantage of using Cilium CNI, which is most famously used rather than Calico. Cilium is getting widely popular, and we'll see why it is getting popular and why it's been adopted by managed Kubernetes as well. So yeah, so we'll see the Cilium CNI, and then we will see a bit about the namespace, different namespaces like pod namespace and network namespace, and what's the Kubernetes namespace. So we'll see all of them today. And then finally, we'll see the etcd backup and restore. Last week, I think some of you are interested in backing up the etcd. Yeah. So we are not going to replicate the exact production. So whatever we have with the kind cluster, we are going to make use of it. So the underlying context will be same even with the self-managed, but in managed Kubernetes, we are not going to do any restores for the master component because master is managed by the cloud. So there we don't have to do any of this work. Okay. Yep. So let's dig into the architecture. So the last week, what we have seen the Kubernetes architecture. So there are two components. One is the master component and the worker component. So these are the left hand side, you will see this is the master node, and right hand side is the worker node. So master node is the control plane. Basically, it does not have any containers running for the applications. So it has its own containers for managing only your master. So basically, what are the components that it has? Scheduler, Kube controller manager, and other controllers as we have discussed today, and etcd. etcd is the database. So where your desired state is managed in the etcd database. So etcd is your heart, I would say. If the etcd fails, then your cluster will not have any desired state and it will continue to fail. And scheduler is primarily for scheduling your pods. So it decides on which is the right node, and then it based on the algorithm, it checks which node a new pod whenever it comes in, it checks which node is apt for that pod, and then it instructs the API server, and then the API server will connect to the kubelet on the worker node to schedule the pods. So that's the work of scheduler. So when scheduler is down, then obviously your new pod will not be scheduled, and even your restarting pods will not be scheduled. It will keep on in the pending state. And controller manager, we have different types of controller as we discussed. So controller is down, then none of the existing state will still remain. So any new node or any pod, any jobs, anything which comes in new will not work. So that's the major use of controller. And API server. So this is the brain of your cluster, I would say. So whenever you run any command against your cluster, the entry point is this API server. Okay. So the API server is the one that connects to your etcd database, and then scheduler talks to your API server, and even the controller talks to your API server. So all forms of communication that goes from the API server. Okay. So API, if you know the advantage of using the API server, if it goes down, then again your cluster state will be down, because even though your etcd is up, your API server will not going to respond to any of the requests. So these are the two critical components. It has to be up for your cluster to be up in the self-managed. But when it comes to manage, again I'm saying these are the master components. We don't manage, we don't see them at all. So how it is managed? It's managed by the cloud, and they will have high availability, and then we don't see at this at all, and we don't debug these things there. So all that. So with that being said, let's come to the data plane. Data plane is often your worker node. So control plane is basically does all your controlling works. Okay, so it's not going to host an application pod inside the control plane. Okay, so it has a taint that taint or toleration, and then node selectors will be there. It is marked as system critical. It can only run system critical pods. So the control plane nodes I'm saying. So that your application pod will not go and schedule onto them. It's dedicated for your master components. Okay, but wherein the kind cluster, we don't have any such taints or enables that is attached. That's how we are using one node, and then all our application pods get scheduled. So, but in the real time, so it will have a taint and the label. So we'll look at what is taint and label. For now, you can think of like, if you taint it, or if you have a label, then if you mark that as a system critical, only system critical pods will be scheduled on to the master nodes. So just imagine, like not all your application pod will run in master. Okay, it has to run on your worker nodes. Okay, just imagine like that for now. So we'll look at more on selectors, affinity, taints in the upcoming sessions, not today. And let's look at the data plane. And data plane is nothing but your worker nodes. It is a virtual machine. So be it a self-managed, it is a virtual machine that's created by you, or be it a cloud, your Azure virtual machines will form a node group or node pool, they say. So then that will be attached to your master node. So these worker node is completely responsible. We are the responsible for this to maintain, be it in a self-managed or cloud provided. So we have to take care of it. So cloud is not going to manage this. So it is our responsibility to have it healthy. So in the worker node, what are the components? We have Kubelet. So your API server will talk to the Kubelet component, and this Kubelet component is the one that will get connected to the container runtime. So what is the container runtime? Any idea from the last session?
Which will create the containers by using the container DR, CRIO, CRIO.
Yes, exactly. So it's a container runtime, CRI they say, container runtime interface. So based on their Kubernetes standards, if they are following, there can be lot of container runtimes. So famously available is CRIO, and Docker was being used, but it is all deprecated nowadays. So CRIO, RKT, and Runc. So all these are primarily used container runtime. So basically for creating your images, Docker containers. So these container runtime is responsible for it. And then Kube Proxy, we have a separate component called Kube Proxy that is managing your service routing within your cluster. So whenever there is any request from the client means it can be from the browser, if there is or from the internet. So if you send any traffic to one of your application, so first thing that it comes is the public load balancer, and then it comes to your service. So that service level routing comes until it reaches the service. Then until it reaches to the pod, the service to pod level routing is managed by your Kube Proxy. So Kube Proxy does service networking. So that means service to pod level routing is managed by your Kube Proxy. Okay. So that's on the recap of our last session. So let's see, in today's session, what we are going to see. We are going to see what's the difference between these. So last session, we have seen more about pods, right? So this session, we are going, so who will create the pods? So the pods are created by any one of these manifest Kubernetes objects, I would say. So these are inbuilt Kubernetes objects. So these are the three majorly used Kubernetes objects which will create your pod. So you are not going to create a pod directly. So you have to have a deployment to create a pod. So in the deployment, so what's the difference between these three? Deployment, StatefulSet, and DaemonSets. So when you create a deployment, last session we have created Nginx deployment, and then you have seen multiple instances of it. So if you have visualized how a deployment looks, I'm going to create a quick deployment. So this is a simple deployment reference. So if you see the underlying pods, so the name of the pods are with random numbers. Okay.
Yeah. Sorry, your screen is stuck at the deployment page.
Okay. Is it? Do you
Yes.
see the Kubernetes KGP?
No.
Okay. Let me reshare. How about now?
Yes, now we can see the
No.
terminal.
Okay. So this is a sample deployment. So deployment will create pod. That's what I said, right? So if you see the pod, these are the pods, Nginx pods. Okay. So it has a random numbers assigned to it. So that's because we have created 4 different replicas, and there is no in the deployment.
Sorry, how did you log into this terminal, and what is KGP? Is it short form or?
So basically it is kubectl get pods. That's the short form. So I will show you in the lab. Maybe you can create a kind cluster yourself. So is this your first class, Ganesh?
Yes, sorry. Yes, sorry for that. Yeah.
Okay, no worries. So in the lab, we are going to see how we can create a kind cluster, and then how to create a deployment. So basically I used the imperative way. So this is the imperative way. You can create the deployment from the YAML file as well. So in the Kubernetes, there are multiple ways to create the pods. Okay. One such way is creating using imperative command. This is the imperative command. So we use the kubectl CLI to create these deployments. For now, I'm showing it with that way. And then, yeah, so let's see other ways in the upcoming sessions. Okay, so this is the sample deployment that I created. So it is running in a kind cluster, so which I created just for this demo. And so I will show you in the lab how to create them and how to use them. So kubectl get pod is a command to check the pods that are scheduled, and KGP is the alias. So both will be same. We will bring the same output, but yeah, and we have multiple ways. So with the alias, I'm bringing up all the pods that are running in the default namespace. And then if you see the pod numbers, it's of a random numbers. You cannot decide on what will be the number. So it is a random generated. So if you see the PowerPoint, it will have a pod and then random numbers. But wherein your stateful set, you will see pod will not have a random numbers. So it will be assigned with the specific numbers 0, 1, 2, like that. So if you create a stateful set, you will see them as a dedicated pods. So you will not have a random number. So that's what the stateful set is. And what is the use of stateful set? It is for stateful application. So for example, for deployment is a stateless application. Stateless application in the sense so stateless application in the sense it can restart any number of times and then it can share the network storage and networking, but even your restarts and then filling of pods, cleaning of new pods is not going to affect anything to your application. Okay, but wherein in your stateful architecture, each and every pod will have its unique storage, unique volume assigned to it. So it will have pod 0 as a pod name and volume as volume 0. So the persistence volume, that we'll see it in future classes. We are not going to deep dive into stateful set for now, so we will visualize it later. Okay, so basically it has its own volume, it has its own pod. Each volume will be assigned to this pod specifically. Okay, and coming to the daemon set, which is the third one. So
Sorry, Lavanya, again your screen is stuck in the terminal.
okay. So maybe if you can open up the.
Actually, it's giving access denied for the link you have shared.
Okay. Anyways, I will share it. Is it better now?
Yes. Thank you.
Okay. So what's the difference between the deployment stateful set versus daemon set? So the stateful set and daemon set, it is going to create a pod based on the number of replicas that you define. Okay. So basically in the deployment, you will have replicas defined. So based on the replicas, it is going to spin up. So replicas 4. Is my screen visible?
Yes, it is visible.
Yes. Both for the stateful set and for the deployment, you will see the number of replicas mentioned, and that many pods will be running. But when it comes to daemon set, each and every node will have a pod. So that is no concept called as replica set. For example, if I have three nodes, and then I should have 3 pods. So for example, what is the best example for daemon set is your Kube Proxy. So Kube Proxy runs on every node, that is 3 spinned up in your cluster. So why we need Kube Proxy on every node? To do the service management, to do whatever the pods that are assigned to it. So you need IP tables and all, everything to be actioned on to those nodes. So you need Kube Proxy on every node. So Kube Proxy is a daemon set. And your CNI will also be a daemon set. Okay.
Sorry to interrupt. I'm seeing only the slides, but should we follow the terminal or slides?
Okay. Okay. Then I will try to reshare every time when I switch. Yeah, I think we'll have to sort this out. Okay, I think you should see the terminal now. Do you see that?
Yes.
Yes.
So this is a sample daemon set. So you won't see the replicas parameter here, but wherein in your deployment and stateful set, you will see the number of replicas. Okay. So the command to get the daemon set is kubectl get daemon set dot apps hyphen Kube namespace. Hyphen n is your namespace and Kube Proxy is your daemon set name. And then if you give OYAML, it will give all the Kube Proxy configuration as an YAML file. Okay. And then you can also do KGDS. KGDS is an alias. So it is also going to do the same. So similarly, you can do the deployment dot apps or just deploy. So these are all aliases. So it's all going to bring up the same. So Coming to the daemon set, so every node will create a daemon set. So one major examples of having a daemon set is your Kube Proxy, your CNIs, and node exporter. In monitoring, you need to have collect all the metrics from the nodes. So you need to have a node exporter to collect all the metrics. So node exporter is one of the daemon set. So similarly, whenever you deploy anything, for example, if you use Istio service mesh, it has its own daemon set. So each and every tool will have either a deployment or daemon set based on its usage. Okay. So that's so we have
Two questions. Sorry. Daemon set is mainly used for this monitoring and side task. So for those kind of tasks, right? So I am not clear with the daemon set. Meaning, what I have seen is the APM task or a monitoring related metric. So if you need to push and pull mechanism kind of things, I have seen the daemon set. So is that the purpose of it, or are there any other use cases? Can you hear me?
hello. Sorry, I got dropped off. Just rejoin. Am I audible?
Yes, yeah.
Yes.
Sorry about that. So my screen is visible, right?
No.
Are you seeing the screen now?
Yes.
Yes.
Okay. So coming back. So what is a daemon set? That's what we were discussing, right? So for every node, if you deploy a daemon set, a new pod will be scheduled. So most widely used daemon sets are Kube Proxy for any networking related stuff and CNI related stuff. So those will be created as daemon set. And for monitoring as well, we'll have a daemon set. And for service mesh, STO. So all these will be definitely deployed as a daemon set. So wherever there is a node level operations, for example, in your service mesh, it has to deploy a sidecar onto every pod. So service mesh is one of the places where daemon set will be there. And CNI, of course, you need to have networking between the nodes and pods. So for that reason, your CNI should be deployed as a daemon set. And same like Kube Proxy is also one of the daemon set. Okay, so if there is a new node that comes in, a pod will be in that node. Again, that is a daemon set. So if a node is removed, again the daemon set with respect to that pod will be killed. Again, there will be less count. So whenever there is a node, imagine there is a daemon set that will be running on that node. So number of nodes is directly proportional to the number of pods with respect to that daemon set. So we have 1-to-1 relationship, one node, one pod for a daemon set. Did it answer your question, Ganesh? So other primary examples are FluentD is a daemon set, and Prometheus Node Exporter is a daemon set. Networking, CNI, Cilium and Calico will have a daemon set, and again for storage, CSI driver is also one other example for daemon set. So we have seen a deployment daemon set configuration, but behind the scenes, the pod templating between all these will be common. So yeah, we'll look at the pod templating in some time. Yes, Ganesh?
Sorry, I hope I can ask a question in between the sessions. Is it
Yes.
okay? Can I go ahead? So, for example, if I have a
Yes.
Kubernetes MCP server, can I run it as a daemon to collect, daemon as a sidecar to collect the metrics from the application? For example, I want to I want to communicate via MCP server to the application parts to troubleshoot, for example, right? So for that, I'm going through a sidecar. Then can I use the MCP server as a daemon set? I'm just asking because I'm not very sure about that, and I'm still researching on that.
Basically, MCP servers with respect to Kubernetes, it has to talk to API server. Not necessarily it has to be deployed as in a daemon set. So it also depends on what you are trying to do. So with respect to sidecars, so sidecar is also a different tool. So what you are connecting with your sidecar, you don't need to connect to every node, right? All you just have to connect to the Istio namespace and then have a collect from the metrics itself, you can visualize what it is there, right? So you don't need to have a daemon set. I'm not sure what is the purpose of MCP server, but for Istio sidecar, what it is going to do, we'll have a separate session on that for the
Okay,
service
then
mesh.
it's fine.
Basically,
Yeah, thank you. Okay,
Yes.
my doubt was on sidecar actually. So I thought
Yes.
we could do that via daemon set also. So I was wrong. So yeah, my question was related to sidecar. Then I'll wait.
Yes,
Yeah.
we'll have to wait for the monitoring session and also for the site Istio service mesh session. So there we will connect all the details. Okay. So moving on to the next slide, which is the traffic flow. So we are going to see the traffic flow today. Is my screen visible?
No, not the sliding part. PPT.
Okay. Do you see the Lucid app?
No.
Yeah, terminal is visible right now.
Terminal.
Okay. I don't know why it is giving that issue. Maybe someone knows, like switching between the screens. Just let me know. I can do it better.
Are you sharing the entire screen or by application?
So I have two monitors.
Yes, yes.
That's what we did.
So if I click on screen share, right, it will give you three options. I always select the entire screen, and then I select that particular monitor, and then whatever the applications I want to switch, I keep in that monitor only. For example, I have terminal and PPT, then I keep both the applications in that particular monitor what I'm sharing, so that you can tab, that's it, within that monitor. Otherwise, we'll have to switch between, we'll have to stop and reshare again and again.
Okay. I did that now. So, is it visible now? Like the
Yes,
I
it is.
share the screen instead of window. Okay. So normally how a traffic flows. So this client is nothing but your browser or from anywhere from the internet, you're sending your traffic. So the traffic will be intercepted by your service. Service in the sense, I'll tell you what's the service for those of you who don't know. And then you can have multiple pods for an application, right? So you'll have different pods for a single application based on the number of instances that you configured. It will have that many pods. So this is how your traffic flow will be in your normal scenario. Okay. So a client sends traffic, and first it reaches the service, and then it eventually sends the traffic to the pod. So not to the entire all the pods. So it picks up only one pod and sends the traffic at that time. So this is based on the algorithm that is being used. So primarily it has to be a round robin. For some case, we might see the same pod getting having a traffic routing. In that case, we'll bring up the Istio service mesh to do the better routing. So for now, you consider that it can send traffic to any of these pods. Okay, either pod 1, pod 2, or pod 3. So one pod at a time. But how that is done, this is based on the algorithm, static algorithm that is defined, and then it should pick up one of the endpoints. But this is without any ingress or without any load balancer. Do you think from internet you can reach your service? Any guess?
No, Lord.
So we should have some public facing thing to reach your services, right? So this has to be your ingress controller or load balancer. So these are public facing endpoints. Okay, so with the public facing endpoints, you can reach your services. Okay. So basically, the client cannot directly send traffic to service. So in between, it has to have a public IP, so which is accessible from your internet. So from the public IP only, it can reach the service. Okay. So this public IP can be directly a load balancer. So sometimes it can be a Meta LB or Azure load balancer, or specifically Azure public IP. So it can be any of the combination that is being designed for the company, or it can have it. So there is a concept of ingress that's replacing these load balancers. So for example, I have 10 applications. So do you think we'll have 10 load balancers? So each and every load balancer will be associated to a public IP, right? So if you keep on increasing the public IPs, then every public IP is chargeable. So the cost will inevitably grow. So we should not be using a load balancer in a production application, right? So hundreds of microservices you deploy. So you cannot have 100 load balancers. Then your cost of your load balancer will be higher than your cost of your cluster. So in that case, we should not be using this load balancer. Instead, we have to have ingress controller, and widely used ingress controller. So basic ingress controller is Nginx, and Istio is providing advanced capabilities like service meshing capability. So we are covering Istio in our upcoming sessions. So we will see more about how it does this load balancing thing. But for now, ingress controller, you imagine Nginx or Istio. Nginx is a basic ingress controller and Istio is an advanced level of traffic routing. So you need to have any of this upfront to route your traffic. So for example, if you have app.com, app1.com, so then it has to reach, if you get app1.com, it has to reach this pod to service your application. So what is the advantage of using Istio or Nginx? It can provide a path-based routing. For example, app.images or app.video. So these are each are different applications. So this, for example, app1.com homepage is this one. So similarly, you will have another set of application called video, and it will send its traffic to that specific service. Okay. So it has a different service. So path-based routing is possible. So single endpoint. So not every company will have a different endpoint, right? For example, I am running a company which is called the Matrix Cube Technologies. So I cannot have different domains for each of them. Instead, /video /training / services offered. So each and everything will have its own application running behind the scenes. So these are all path-based routing. So basically this ingress provides that feature. So with the path, you can route to the right application. Okay. So we'll see in detail how this path-based routing is achieved during our ingress sessions. Okay. Yeah, I think someone raised their hand. Ganesh, is it you?
Yeah, Nginx is decommissioned now, and everybody starts using.
Yes, Nginx is deprecated in 2026. So it is replaced by Gateway API. So we will see. We'll see that.
Okay.
Okay. So Nginx is very easy to provision. Similarly, Gateway API. So if you understand the underlying concept, it's going to be the same. The only thing that gets changed is the API. So the API in the sense, this one.
So Gateway API meaning, for example, Kong. Some platforms can have their own gateways, API gateways, and then they can.
There are a lot of. There is an inbuilt API gateway. You need to install it as a controller. So the Gateway API is provided by a lot of tools. Even your Cilium has a Gateway API. So even your Calico has its own Gateway API. So you can make use of any of it that comes along with it. So you don't need to install specifically Ingress Nginx. Rather than you migrate your configuration from Nginx Ingress to the Gateway API. Or directly you can use the Ciliums. Or if you are using Istio, you don't need to bother about the Nginx at all, right? So already you're using Nginx, which is way more advanced and provides much capability. So for those of the companies who are still using Nginx, this is a problem. So they will have to migrate to the Gateway API. Gateway API is specifically designed to replace it, but this Gateway API is a controller that gets installed onto your Kubernetes. Specifically, you will have to install them, or you can make use of external Gateway APIs that comes along with your CNIs. Okay. Did that answer your question, Ganesh?
Kubernetes, right? This is mainly for Kubernetes, correct? This Gateway API and all those things. Okay.
Yes. So, for example, the only thing behind the scenes, it is going to do the traffic routing. So, the change that you will see is here in the API version. So, basically, this will change. So, if it is an Istio, you will have API gateway.istio.io. If it is from Cilium, it will have API gateway.cilium.io. Or if it is a Kubernetes, it's k8s.io. That's it. So that is the change that you will see. And if it has a different syntaxes in the specs, it will vary. But underlying concept will be the same. Okay. Are we clear? Yeah. So this is the traffic flow. Anyways, we have discussed it already. So let's move on to Kube Proxy. So Kube Proxy, as we discussed, it is going to perform our service networking. So I'm going to show a demo today, how it is all working behind the scenes, and then you can follow along. So maybe after the session, you can do the lab yourself. I'm going to give you all the details, how to spin up the clusters, and then how to perform the lab. Okay. So let's move on to the slide. So for example, the Kube Proxy is a worker node component. So that we are clear now, right? So coming to the Kube Proxy, what it does, it runs on each and every node, and it is a daemon set. So each and every node will have the Kube Proxy. And in the Kube Proxy, basically what it should have all the pods. Pod related details will be there. So for example, I have a service, KG service. So if you see this, basically this service is going to send the traffic to your backend pods. So this service is specifically for pod demo service. And how many replicas we have? We have 3 replicas, right? So 3 replicas, KGP, and O-wide is going to give me details about the IP. KGP is a kubectl get pods, and then O-wide is giving me additional information. So if you just hit kubectl get pods, it gives you basic information. It's not going to add the IP of the pod. So for getting the IP, I'm giving O-wide for some of you who don't know. So if you see the IP of these pods, like pod demo, it has 3 IPs, right? 10.244.0.854. So these are the 3 IPs. In the endpoint, it will have these 3 IPs and along with the port. So that's how it knows if there is a traffic that is reaching this service, it has to send the traffic to any of these pods. So we will see that how it looks like in the IP tables. So this is from the Kubernetes API point of view. We are seeing this information. So in the networking side, we will also see how this is visually looking. Okay. So for now, you know what is the endpoint, what is the service, and what is the IP that is assigned to the pods, and what is the service IP. So each and every service will have its own IP. So these are the service IPs, and these are the pod IPs. So if you see, these both are in different CIDR range. It should not have a conflict within a cluster. So you'll have to design in such a way that these two are mandatorily different IP ranges. Okay. So this is the service IP. So whenever there is a traffic that comes in, it comes to that IP, and then from there it is sending traffic to the respective pod IPs. Moving on to the slide. So I'm going to show this service networking in the Kube Proxy lab. So just wait for it, because it is then we will see this diagram again, how it is and what we have seen. So let's move on to the networking, different networking that's there in the Kubernetes. So basically there are different namespaces that are there. For example, in the Linux world, it has network namespace, something called as a network namespace. There you will have a interface called as ETH0. So that's the network interface card. So that is how it is called in the network namespace. So we are going to see now what is the pod network namespace and what is the root namespace that comes with Linux, and what is the Kubernetes namespace. So there are 3 different namespaces that are there. So basically we will deal with the Kubernetes namespace only with respect to kubectl, but behind the scenes you just have a small idea about what is pod namespace and what is the Linux namespace. So what is a pod namespace? For example, pod can have multiple containers, right? It cannot have, it need not to have one-to-one relationship. So it can have application containers, it can have monitoring containers, and it can have sidecars, init containers. All these containers are there. But what is common between these are all in the pod network namespace. In a single pod, you will have multiple containers, right? So what is common between these? So this is a shared namespace for that specific pod. So any volumes that we are creating with that pod, so it will be shared by these 3 containers. So for example, if you create a volume and map it to a pod, the storage will be shared between these. There is no restriction between them. So that comes in your pod network. But when it comes to kernel networking namespace or root networking namespace, so there you will have all the devices like devices, and your CNIs will be coming in place here. So these CNIs, you have a different network namespaces, right? For in node 1, I have a network kernel network, and node 2 have a kernel network. So these two has to communicate so that whenever there is a request, you need to have a communication between the pods. The pods is not running onto a single node, right? It is running across all the nodes. So you need to have such information. How it is done? It is done by your CNI. So that's why CNI is very important when it comes to this networking. Okay. So there are two types of namespaces. One is pod namespace, where your resources are shared between these containers. Specifically, your storage volumes are shared within that pod. So any number of containers, it can access that volume. So there's no restriction in the pod network namespace. But when it comes to networking namespace, so it is acting on the kernel level. And basically your IP addresses, network interfaces, route table, firewall routes, everything will be running inside your root namespaces. So yeah, that's about it. And then let's look at the third thing, which is your page. So yeah, let's visualize it in two different applications. So you have two different pod network namespaces. This is the first pod, this is for the second pod. So how they communicate? They don't communicate directly here. So they communicate through the root namespaces using the CNIs. So CNI we spoke about is we have Flannel, we have Kindness for kind clusters. But when it comes to production, your Calico or Cilium does this job for you. Okay, these network namespaces are handled from your CNIs, and then those are provided by different tools. Okay. So just again, we are looking at the architecture. Client, it sends traffic to the service, and then in the node you will have a Kube Proxy. Kube Proxy is a DaemonSet, so that's how it is there. That's why it is scheduled onto every node to route the traffic to the specific pod. The Kube Proxy has details about the pods, and then it sends traffic to the alive pods. Okay, so let's move on to the lab. And in the lab, so we are going to create a kind cluster. And then we are going to run the IP tables command. And then we will see how, whenever there is a new pod gets assigned, how the IP table changes. Okay. So, yeah. Any question?
Where the root network namespace exists? In the Kube Proxy?
In the
Or
kernel.
like
Linux
in the
kernel.
Linux kernel. Okay.
So,
So
it,
Linux
Linux
kernel,
network
I'm a little bit confused. Like we have a control plane and we have the worker nodes. Okay, in the worker nodes we have a pods. So where the Linux kernel exists, like Linux kernel is in the container. Like in the container we use the Ubuntu machine or the
what's the virtual machine?
Virtual machine is like a operating system.
So which operating system we are using?
Suppose Ubuntu.
So which OS image we are using for our demo?
Debian.
Yeah. So that's a Linux kernel, right?
Yeah. Okay.
So this network namespace is not the concept that's coming only for Kubernetes. So whenever you involve any operating system, Linux-based operating system, these network namespace will be there. So it's not that we have invented in Kubernetes. So that's the concept of Linux kernel isolation mechanism. Okay. So that's where whenever your pod is getting assigned, what is the underlying thing that is added? It's your network interface, NIC, right? NIC. So
Yeah.
that is attached to your pod the pod IP will be attached to your pod in the front end, but behind the scenes, it has to talk at the kernel level, right? So it has to have a network interface, NICs, and then IP address, routing tables, firewall rules, that all happens at the kernel level. Okay. So don't think that it happens at the container level. Container level is a pod network namespace. Okay. So that's different. So network, this kernel level namespace, that's doing all these things at the kernel level, not at the container level. Okay. So these two are different. So let me bring up that diagram again. So in the pod level, just the containers and pods are involved. But when it comes to the network level, all your NICs, IP routing, CNIs, bridge networking, everything will be here. So maybe you can, I will give you some references. You can read more about it if you don't have a clear idea even now. So you will get to know what's exactly the difference between. So basically it's running on the OS level. Okay.
Yeah, sure.
So without in Kubernetes world, we are not going to dig too much into this network namespace. It's on the Linux, so we don't do much of a troubleshooting. So just understand there is something called as pod network namespace and kernel network namespace. Okay, so these are the two things that is there in the node level. But there is another thing called as Kubernetes namespace. Any idea what is Kubernetes namespace? So just forget about all these things. These two are different concepts. We are going to see the third one, which is the Kubernetes namespace. So you know what is pod network namespace and network namespace, at least a bit of an overview, not in depth, but you can, if you are interested, you can read more about it. So now comes the Kubernetes namespace. Any idea what is it?
Yeah, to isolate different workloads, like in multi-tenant architecture, we use namespace technology.
Yes, exactly. So Kubernetes namespace is not a OS level isolation. Okay, so it is not going to define under OS level. It is on your Kubernetes level. It's on the logical grouping. So it's just a logical grouping. You cannot visualize it in the kernel levels. So for example, I will tell you why is the use of namespace. As Swarna said, so it is basically for multi-tenancy. Okay. For example, I have different teams. Okay. So there is a HR team, there is a finance team, and there is a development team. So for an application running inside a company. So do you think we'll spin up 3 different clusters or 5 different clusters based on the number of teams that we have? No, right? We should have a single cluster to manage all their application. But do you think an employee can see the finance related details or HR related details? No, they should not be seeing each other's details. So there should be a state isolation, right? So we should have a right mechanism, like right RBAC provided, who can access what. Only HR team can access HR namespace. So only finance team can access finance namespace. So namespace is a logical isolation in the Kubernetes cluster. Okay, so it's not at the OS level. So it's for your application segregation. So what do we do with the namespace? We restrict the access for multiple teams. So basically you can, in the SaaS platform, even different organizations, so different companies can have their own application running inside. For example, I work for one of the hospitality industry where lot of major hotel industry is there. So they don't manage a single cluster. So they don't manage each and every, for every customer, they don't manage a single cluster. For example, for hotels like ITC and for hotels like Milton and all these things, they should not have a separate environment for each and everything, separate cluster. So instead, what they can do, they can have a cluster, they can have a single cluster, and within that cluster, they can have namespaces. So for Milton client, they can have one namespace for them, and then for the other ITC, they can have one for them. So this is how they can manage the access between these two and have a multi-tenancy within the cluster, and even the cost will be reduced and the complexity that we need to have multiple people to manage cluster upgrades, cluster management, day-to-day operations. So it's better to have a single cluster, generic cluster created for all of them, and then just manage it via namespaces. So namespace has, so you cannot access the app. You can have a restriction between the applications between these two using different things called network policy. You can restrict the applications. Okay. So, and also define this namespace can have only this much quota. So I can only assign 10 cores and 100 GB resource for them. So for example, I have a small team. Okay, so that team needs only 100 GB and 10 cores. So I can assign only that compute capacity to this namespace. But wherein I have another team, so B team, they need more compute resources. So that I can assign them 1 TB also. And then I can assign 100 cores of CPU because they are using intensive application. So that the revenue goes, right? So you can define the quotas for each of these namespaces. So first thing is multi-tenancy. Second thing is the resource quota. So you can allocate the resource limit for them. So if they exceed that quota, they will not be able to schedule any new pods. So then they will have to come up to you, and then you decide on whether you are going to allocate more resources for them and then change it and then tight RBAC. So each and every team will get their own AD groups. For example, if in the Azure, you will have an AD group, AWS IAM roles, right? So you can have a specific groups for them. HR will have their HR group, and then finance. And so you provide access to that group. Whoever the member of them, they can only access to that namespace. For example, HR team should be assigned with the right role and role binding, so they can only access HR namespace. And similarly for finance or for the other development teams, right? Other training namespaces. So that's the concept of namespaces, and that's how applications will be segregated in the Kubernetes setup. So it's basically logical grouping. So it's not at the OS level, it's at the Kubernetes API level. Okay. The container, and then basically for resource separation. So how do you get the details? Kubernetes. In the Kubernetes, you can run this kubectl get namespace. So these are the namespace. So this kube system, it gets created whenever we create a cluster. So what are all the pods that are running in kube system? So this is for those who have not joined the last class. So kube system, since it is a kind cluster, self-managed, so that's why you're seeing API server, controller, manager, Kube proxy, scheduler. These are all master components. Okay. And this you're seeing another pod. We have not discussed too much of it. This core DNS. Core DNS or Kube DNS, they say. So initially it was named Kube DNS, and eventually it was renamed to Core DNS. So what is the use of this Core DNS? So it has the capability, it knows it is a DNS resolution for your cluster. So it has the capability to only route traffic within your cluster. Okay. So all your traffic routing. So DNS to IP mapping. For example, if I call one service, then it has to go to Core DNS, and then Core DNS will have the routing details, since it is a DNS server, local DNS server for your Kubernetes. So it does have the details of which service, where is that, which namespace, and which ports, all these routing details it has. So it is a mini DNS server for your Kubernetes cluster. So that's the, I think we didn't speak about it, but we'll see when we cover, as in when we cover the DNS part somewhere. So basically, if this is done, what will happen? None of your traffic will go within the cluster, and also to out. If you are sending any traffic outside of your cluster, for example, you are accessing www.google.com. Okay, so that will also not work if this goes down. So within your again your Kubernetes cluster will be down if there is no DNS mechanism that's working, right? So this is one of the important components. Okay. So sometimes you have a default DNS server, and sometimes people bring a custom DNS server as well. So that will, I'll show you what is a custom DNS server. So basically it is primarily used in the private cluster. For example, the private cluster, they will have to have a DNS. Since it is a private cluster, they will have to have their own DNS servers, and that DNS server is the one that sends all the traffic. So this core DNS server can be configured to route all the traffic through that DNS server. So that's the major advantage of using the core DNS server. It can be customized. So it can. So now we are using the inbuilt core DNS server. So basically, if you consider core DNS as your DNS server within your Kubernetes cluster. Okay, so this one we haven't talked about. And the etcd is again your key store database. All your state will be stored in your etcd database. Let's see if we have time today. We'll do at least backup and restore of etcd database. Okay. Yeah. So any doubt in namespace? Okay, good. Then can we move on to the lab of IP table? I think possibly you can all connect to this repository which I shared in the chat. And then under week 2, you have all the details for today's lab. I have a README file in week 2. So what we are going to see, we are going to create a kind cluster. We are going to visualize the IP tables. And then when the new pod gets assigned, what happens to the IP tables? What is the drawback of Kube Proxy? We'll discuss that also, because we have a replacement for it that we will see it in the upcoming class. So, yeah. Everyone has kind installed on your WSL terminal, right? For those of you not installed it, install kind CLI on your WSL terminal. You should have enabled by now WSL terminal if you are using Windows. If you're using Mac, just the terminal should work. Okay. So I am in under week 2. So now I am going to create a cluster called IP tables demo and with a kind configuration. Okay, node already exists.
Kind git
If
clusters.
you are able to run the kind cluster. Are you able to create a kind cluster? You should be, because I did create it previously. That's how it has the details. Okay. Are you able to create kind cluster?
Yes, love. It can be any version of K8, right? Or specifically
Yes,
need to be. Okay.
So yeah, any version of K8 should be fine. There's nothing like so any version will have the IP tables. So we are going to visualize mostly the IP tables work, right? So it's fine. No worries. You don't need to specify any version. So my kind cluster is getting created. And I'm going to just check the nodes. Okay. I see all the nodes are up. In time before running it. So the proxy, Kube proxy is a daemon set, I said, right? So how many nodes we have? We have 3 different nodes. So KG nodes is kubectl get nodes, the number of nodes that we are having in the cluster. So each and every node will have a pod assigned. If it is a daemon set, it will have a pod. So you should see 3 different pods if it's a daemon set. Okay. And this is a CNI. CNI is also a daemon set. That's why you're seeing 3 different pods. So basically, whenever you create a vanilla cluster, some compute instance will be allocated to the node. So this is one of the interview questions. Like, for example, I have a node, 8-core CPU and 16 GB memory. Can I use 100% of it? No, right? Because all these are created by default. So it has its own resource allocations. So you have to at least, you can only use until 80% of it. So if there is a question like there is a, if I have a pod with 500 MB and then 1 core CPU, then how many pods it can be scheduled? You don't answer like 100%. You don't do a math calculation and schedule the answer like 100%. Give something like 60 to 80%. Okay. Otherwise, then you cannot 100% utilize the capacity that is coming out of box, because these are some of the pods and it gets scheduled. It has its own IP, resource request and limit assigned to it. Yeah. So that's about the daemon set. And then what we'll do now? So I'm going to create a deployment. So this is the imperative way. So this is not the production ready method of creating the deployment. I think I've already created a deployment with 5 replicas. So I'm creating a deployment called Nginx. Then primarily we are using Nginx as our demo deployment. Okay. And the image is Nginx. If you don't give a tag, it will take latest Nginx image tag. And then with replica count 5. That means you will have 5 different pods. Okay. And then now I have created a deployment. So which only created the pod. But how will I expose it? I have to use the service, right? Then only it can expose the application within or outside. Okay, so I have exposed the Nginx deployment. So we don't have a domain. We don't have DNSs assigned. So for now, we are going to port forward this and access the pod. Okay.
Lavanya, your screen is stuck.
Okay, let me reshare. No worries. Should be visible now. Please confirm.
Yes.
So since I ran before, I'm getting this IP address. A port is already in use. So ls of command, it will give me the port that is being used and what is the process ID. I'm killing that process ID so that I can successfully do the port forward. Port forward is nothing but accessing your application locally without making use of load balancers. Okay. So if I open my browser, I will see the Nginx. So this is my Nginx application. Okay.
In Lavanya, can't we port forward a running process?
No. you have to put forward your pod or service. Okay, so I have put forwarded, and now what I'm going to do, I'm going to connect to my control plane. Since we are making use of kind cluster, so all your nodes are a different Docker container. Okay, I'm logging into the demo control plane, which is one of our master, which is the node, that's the master node. Okay, I've connected to inside the control plane. So how to check the IP tables? This is the command. IP tables -nat -l means list all the routes. So this is how it is. So lot of pods, right? So let's see.
What the NAT argument does it tell like outbound traffic or something?
So NAT is providing the network address translations. So we are specifically mentioning the NAT command. If you don't mention that also, it will still list. So you'll have to have some filtering. Otherwise, a lot of IP tables will be shown.
Okay.
So there are different types like output, NAT. So basically, we are interested in network address translation.
Okay.
So if you see here, list of IP tables. So you are seeing different types, right? Target. These are the chains that it has. So different types of chains are pre-routing, input, output, post-routing. So some of them are for Docker inbuilt. We don't care about it. So what we care is our Kube services. So which does our service to pod routing. So this is where all our pods are getting services are getting routed to the right pod. So this is where we'll have to look at it. So Kube services, let's see, for our Nginx deployment. So for this Kube services, we have different endpoints. SVC is the service endpoints. SEP is called as service endpoints. That we'll see how it is mapped. So basically, we are interested in Kube services, where each and every service, whichever we have, like it has one entry for it. So for Nginx deployment, this is the Kube service. So if you look at the chain of this service, so ends with VX, right? So go to the VX. So this is the VX chain. And then if you see here, it will have all our, so what is the source? What is the destination? So this is my destination pod. So this is nothing but your pod IPs that we have, right? So it also has given me the probability, like it will randomly route. And the probability is 0.2, 0.3, 0.5. So based on this, it decides and then it services to the right pod. So for example, if this has high probability, so if I kill this, it will still route to the next pod which has a better probability. Okay. So that's how it is done. So let's look at, so this is too much of information, right?
Yeah, Lavanya, one doubt I'm having. So the source IP would be the services IP and the target IP would be the destination IP would be the pods, right? I mean,
destination will be the pods, yes. Source
yeah.
is the service IP.
Okay, so whenever request is received, the Kube Proxy checks the IP tables and routes the traffic here.
Exactly. So basically, it's a virtual Kube Proxy implements a virtual IP concepts. So it intercepts all your service IPs. So service IPs are intercepted here, and then it checks which pod it has to send, and then traffic will be routed to that backend pod. Okay. So basically, it does the network address translation. If it is on the same pod, then it does not have to do the translations there. So it checks if it is there in the same node, then the pods in that node will be served. Otherwise, if it is on the different node, it does all the SNATing things and then it sends traffic to the right pod. Okay.
Okay, got it.
So different modes are there. So if you see here, so let's finish it up. I'll pull up another console. Okay. And then these route table has lot of detail. So let me filter only the Kube service. So this is only for the Kube services, whatever services we have. So this is for the by default Nginx, by default Kubernetes service, and this is for the Nginx. This is for the core DNSs and for metric server, which is there in the cluster. So for all the services that's there in the cluster, you will have an entry. AG service all. So you will have entry for all of it. Okay. And then you'll have to dig into inside this endpoints to check it. Okay. So now we are listing only the Kube service. So you can also list specifically for one of the services using this command. Just filter out with whatever service you want to visualize. That's it. Okay. So this is fine for now. I don't want to deviate from the topic. Kubelet, delete, pod. So I'm deploying everything in the default namespace. So what happened? No. Copy them. So I have deleted a pod. So now our IP table should have updated. Just a moment. I think I did not filter it properly.
So when we are deleting a pod, is it a graceful shutdown or like kind of immediate shutdown?
Because it's not a graceful shutdown. I'm just terminating immediately.
Okay.
So if I have to restart it properly, then I have to do a kubectl rollout restart of that deployment. So that's not the graceful shutdown. So just for this demo purpose, I'm just deleting it. So you don't need to delete it in the production environment. You just have to do a rollout restart. Okay. So now if you see here, so you'll have to filter it like this, not Kube services. So Kube service will give you the details about the service level chain. But you'll have for the specific deployment, we have to check what service is that, and then you'll have to check the right IP tables. Okay, so here I have 34234. So these are the pod IP, and then I'm going to delete again. So let me pull up the IP before and after. I'm checking the right one. Yeah. 1112. Right. So I told we can use, instead of kubectl, we can use K9S. It is also one of the CLI. Okay. So I'm launching a K9S. From now onwards, I will use combination of these. So you will see the power of it. So you don't need to write kubectl get and then search for it or do whatever, have remembering the alias. So I have these pods. So in the top, you will see like 0 means it lists all pods, and in default namespace, it will list the pods. And then you can describe it, you can edit it here, you can do a port forwarding, check the logs, and execute to the logs. All these are provided within this console itself. Okay. So now I am going to delete. So if you see what's the command for delete, so control delete. So just give control delete. So it's asking me, should I delete in background? It's fine. Yeah. So I'm deleting it. So it goes on terminating state and new pod is assigned. So what's the IP? It is 5, right? 1.5. So if I check my IP table, So 1.5 is updated. So 1.4 is removed and 1.5 is updated. So it is quite in the fraction of second it does. Can you see that? Yeah. Were you able to follow?
Yes.
Yeah. Okay. And I was telling about the methods, right? Methods, like which method it is using. Let me. So Kube Proxy has different types of programs that it can run, either using the IP tables or IPVS. So for now, we are using IP tables. So you can see the modes by checking this config map. So basically, this IP table is no more used widely. So because if you see, we have only single application, Nginx application running. We don't have much load for our kind cluster, right? So imagine like we have thousands of namespaces, right? And then each and every namespace have hundreds of microservices. So consider how much load it will take, how much there might be a noticeable delay in updating all these service IPs, right? Like service IPs to the pod IPs, and it does randomly. Okay, it has to go through the chain one by one, and then for a small cluster, Kube Proxy will work fine. But for a enterprise scale applications, enterprise scale clusters, this is not widely used. So this is being replaced by a few tools like Cilium provides its own method of routing. For example, Cilium provides a eBPF based method. So eBPF is an advanced concept that we'll see it today. Let's see, I think already it's 12:15. Let's see. So this is replaced in the in some of the environments. So have any of you are working in Kubernetes environment where Kube Proxy is being used?
Yes, Lavanya.
So you will not see it until your cluster is grown to a maximum level. Then you will visualize the problem, and also network level tracing is very difficult because it does not have visualizing tool. So do you think that I have 100 nodes? Can I log into each and every node and then check a Kube Proxy and see whether it is updated or not? Or this can also be done using TCP dump to visualize the live traffic flow. So how much TCP dump you will check, how much debugging you will check with the TCP dumps. But that's too much of it, right? So you will not use it. It will not be so much useful when you use the Kube Proxy and does all these things. Debugging is quite hefty. So there comes in our new CNI, which is Cilium. So let's see what we have. Yeah. Any question in IP tables, Kube Proxy?
Sorry, any alternate for Cilium?
Calico? Widely used. These two are.
So this mainly for network observability, right?
Which one?
This main Cilium and Calico, all these are mainly for the CNI network side, right? Kubernetes network.
Yes, for basic. So Kubernetes does not have inbuilt networking out of the box. Okay. So that has to be provided by some of your external tools. So by default, if you are not planning to use any external CNIs, you can make use of the Kubernetes. If you are going for a managed Kubernetes, Azure CNI provides this capability, but it has its own drawbacks. So people are now widely using Calico and Cilium. These two are direct competitors, I would say. So Cilium is getting more and more popular. Calico is pioneer in that field. So Calico was when I started my career in 2018. Calico is having the highest market where Cilium was not even born. So after 3 years, Cilium came into picture, and now Cilium is widely adopted by large companies, and it has a proven credibility as well. So more and more companies are adapting. Even the managed clusters like AWS EKS and Azure's AKS has inbuilt method of providing Cilium out of the box. So they make the Cilium as an add-on. When you create a cluster, you just define which CNI you have to use. You have to use Cilium or Calico. So they provide out of the box tools. You don't need to manage the Cilium. So they manage. So you don't need to upgrade it separately. So they manage the cluster like your master nodes, right? So similarly, Cilium will be managed. So Cilium is mainly for Cilium or Calico, whatever, Flannel or Kubelet. So these are widely used. So these are mainly for Kubernetes networking. So we don't say Kubernetes networking, we say it as CNI, Container Networking Interface. Okay.
So, ma'am, is there any differences between the Calico and the Cilium? Or like we can use any one of them?
You can use. So it's based on your company's decision and also your architect's decision. So basically, I will show you. I have a slide for it. Let me see if I have the comparisons. Yeah. So if you see this slide, these are widely used. So Cilium provides a feature called network policy, and then data is stored in etc. This is fine. Leave out the data storage part. Just check. It provides L7 based routing. Okay, and IP VLAN is inbuilt. So instead of using the Kube Proxy, we can make use of this in the network. Okay, and the Flannel does not have network policy. So I'll detail you what is network policy, and then we'll see in a bit what is the use of network policy. And Calico, it still has network policy, and then it works under layer 3 BGP. But when it comes to Cilium, it works with eBPF. So just read about what is eBPF. I will also try to detail you some of it, because Cilium itself takes around 8 hours to explain all the features that offers. So we don't have that much time. So we'll see what is the architecture and how basically we use Cilium. But if you are interested, we can cut down some tools and then we can cover Cilium specifically for a day. That we'll see. And VNet is another CNI. So these are Kubernetes networking, and we can say like CNI, Container Networking Interface, and then why it is widely used. So another, I used Calico in production, I used Cilium in production. So what is the advantage that I see Calico versus Cilium is Cilium provides very good UI. So because we are going to see the demo now and the lab, so we'll see the UI of it and how it is powerful compared to other tools. So you don't have a UI for Kube Proxy, right? Inbuilt one. So you can't visualize it apart from getting into it. But Cilium provides a Hubble UI, which is majorly the selling point. At one point in time, this Hubble was majorly been a selection criteria for choosing the CNI, because networking and network troubleshooting is very vast when it comes to production. That is where all our energies will go. For example, if your application is down, the first thing that you'll have to visualize is network. What happened when the traffic got dropped? So those level of details we need to have, right? So Calico also has a UI, but they offer it in paid service, not in the open source version of it. But Cilium has a Hubble UI in the open source version of it. Even production enterprise grade applications is running with Cilium. Okay, powered by Cilium. So it's all based on, so to answer your question, there is no apple to apple comparison. So if you see, you need a very good UI, plus it both has a similar features. So if Calico has it, Cilium has the other. So the main advantage of choosing one over other is the observability that I see. So Cilium has inbuilt observability, but wherein Calico does not have in the open source version. So that's one of the driving factors that I have seen in the past in my setup. And Cilium is widely adopted by all the cloud providers as well. Okay, did that answer your question, Ganesh?
Yeah. Yeah. Actually, ma'am, I have like always confused. Can you just open the slide?
Yes.
Uh, last one, not this one. Where shows the comparison. Yeah. So it mentioned IPv LAN with L4 and the overlay network, BGP. So I always confuse regarding these concepts, like what is the eth and the what is the veth and the how routing works, why we use the BGP and why we use the like HA proxy or ingress or the nginx. So I am not very confident about these concepts. So
These HA proxy, ingress, that's different. Okay, leave out those concepts. So just to understand what is Cilium, what is Cilium CNI. So ingress, HA proxy, nginx ingress, these are all your routing tools. So for example, I think we have seen in our in this diagram. My screen is visible, right?
yeah.
So where this Cilium comes into picture? So it comes in here. So let me. So it starts from here. So where it is? It's on the worker node, right? So these services, pods, everything is on the worker nodes. So this is where the CNIs comes into picture. Okay. But you said about HA proxy, nginx ingress. So that comes before that. So for routing, so any of the application level routing, so first it comes to the ingress. So here you are saying HA proxy, I'm saying nginx, istio, all are in the same areas. Okay. So the gateway API, everything will come here. Okay. This CNI, it comes within your cluster. So this is also running within your cluster, but primarily the work of CNI is to route between the service and the pod. But ingress work is out to route the traffic from in the external world to your service. So that's it. So you know the point. Are you clear with it?
Yeah. So, ma'am, like why there is multiple load balancers like ingress, nginx, and the HPA proxy?
So why do we have Calico and CNI? Sorry, Cilium CNI. It has
Yeah,
advantages between these two, right?
Mm.
And they are pioneers in their field. So they are competitors and they are having own selling point, right? So similarly, if you compare nginx and istio, so who will win? What do you think? Nginx and istio. Nginx versus Linkerd. Who will win?
ma'am, I don't have a like deep down knowledge about it.
No worries, no worries.
Yeah.
So nginx provides very basic features. So it does not provide L7 based routing. So I told about this path based routing, right? So this is L7 based routing. Okay. L7 based routing is even provided by nginx also, but your istio and specifically service mesh is defined to provide advanced routing, traffic routing mechanisms like path-based routing is one, and your SSL termination is another one. And there are advanced concepts like service breaking, fault injection, canaries. So all these are features that comes with the controllers, ingress controllers. So choosing one over the other is purely based on your application demands. So for example, you are running a small dev application. Okay, you're into your production yet. So do you think you will deploy an Istio on the first day of your testing? No, right? So you will start with a small minimal setup, nginx. Check whether that should be enough for your application. But when your application grows to a production level, so will you still continue to nginx? No, because you need advanced methods like canary based routing. You need circuit breaking. Whenever there is a huge load, you need to drop your application to go instead of killing your cluster. So you need to have a circuit breaking there. and you need to inject a fault tolerance. So what will happen if there is a fault tolerance injected? So what will happen? Error 500 or 404 is coming. So how long it can withstand, and then the application should fail. So otherwise what will happen if you don't have a fault tolerance or a circuit breaking? It keep on getting the load and traffic, and your application will crash. So you will have to have these advanced features, and of course it has sidecars. The Nginx is not having any sidecar mechanism, so you don't have so much visibility, and then you can't have deep dive into that service mesh capability. Service mesh capability is specifically provided by these tools like Istio, Linkerd, or Console. So these are popularly used. So why do we have? So I'm comparing Nginx and Istio. You can compare HA proxy versus Linkerd as well. So both, one is at the basic level, another one is at the advanced level. So based on your application need or demand, you choose that. Okay, did that answer your question, Priyanshu?
Yeah. Got it.
Okay. So CNI is at routing level, and ingress is at routing your traffic from your internet to your cluster. So basically this is a load balancer, load balancing mechanism of sending your traffic from external world to your cluster. So once it reaches the service, that's it. So inside, how it reaches to the pods and different pods that are scheduled on a different nodes, it's all based on the CNIs. Okay. So the CNI is a overlay network, like the overlay concept that you asked, right? So overlay network is nothing but it has the intelligence of the data that is there in the in all the nodes. So Cilium does that automatically for you. Cilium or Calico, they all based on the overlay network. So you don't need to assign IPs from your subnet. You just have to use them, and then you have to define the pod IP. So we are using a pod sub CIDR, right? So it's just virtual. So you are not, you don't have a virtual network, you don't have a subnet, right, to use the IP from there. Instead, it's all the overlay network that we are using, the pod CIDR, service CIDR. So there is no physical NICs. If that is the case, then we could not spin up a cluster within our kind, right? So it's all based on the overlay network that is configured. So is it clear, Ganesh, on the difference between the ingress and CNI? So where it stands? Okay.
Routing is just to sending the packets, right?
Routing is to send the traffic. So I'm hitting app1.com from my internet. So DNS resolution will happen, right? What is the IP? So that should be your public IP. So that public IP will be attached to your ingress controller, right? Ingress controller's public IP. So that public IP, so based on the app1.com, it knows, it has a ingress rules. So where it has to go, which service it has to go. It is, for example, this service is home service. Okay. So in the app.com, you will define the backend. So this is our backend. So which backend it has to send traffic? It has to send traffic to home. Okay. For example, app.com/video, it has to send traffic to the video service. So all these you have to configure in your ingress rules. So we'll have a separate session. So what is ingress rules? Or what is the ingress YAML? And how we will configure these path-based routing. So we'll cover that there, Priyanshu. So for now, just imagine what's the use of it. Okay.
Yeah, sure.
Okay. Are we good? I think today's class was so much engaging. I'm getting all relevant answers, which is quite good.
Yeah. Is there any documentation for this? Everything is like little confusing. I'm not able to correlate everything because I have never worked on the Kubernetes cluster.
Sure. So at least you get the context of it. And then for Cilium, so this is a in-depth document. For Cilium itself, if you go and check in the Code Cloud and all, it is an 8-hour course. We cannot cover everything here. So we'll try
not just Cilium. I'm confused about like the service and IP assigning part, all these.
Okay. So no worries. We have labs for everything, right? So you will get to, I'll try to brush up everything again and again whenever there is
Okay.
11 things. Okay.
Actually, ma'am, the problem is that like we are learning everything simultaneously. Like, but if we got the prerequisites, like what should we learn first? Like, should we learn first pod or the service or the CNI? So I think we can correlate it with the topics.
Yep. So anyways, these are all the basic sessions, I would say. It's not that advanced level of session. So each and every tools will have its own session, right? So that's the agenda of our master class. So we'll cover each and everything there. For now, let's understand what is the use of CNI and why we are using it, and what is the use of Kube Proxy and what is the disadvantage of it. And then that's what we are learning now. And what is the use of ingress? So rightly asked by Ganesh, right? Why we are using ingress? Why we are using CNI? Why can't we have only one, right? So just understand the concepts, and then maybe I'll give you more details. Maybe I'll detail you where you can check to visualize everything. So I'm trying to give as much of, I don't have any slide contents. I just have only the pictures just to make yourself imagine. Yeah, so maybe I'll try myself. Brush up in every now and then and see how it works.
Sure.
Okay, so let's go into Cilium now. So as I said, Cilium works on eBPF. So eBPF is a Linux kernel level concept. So it's not that it's coming only with Cilium. So a lot of other tools are also using eBPF. So why is eBPF getting more and more attraction? Because it provides more security. For example, all your programs runs as a sandbox program. Imagine something like a box. Okay, all your application, everything will run as a inside the box. For example, if there is any attack that happens, so only that box will be compromised. You will not get access to the kernel level. So because it runs on the sandbox program. So just imagine all your kernel level things will run inside that box. You will not have a wide accessibility to the OS. So that is the main advantage of using eBPF, which is called as extended Berkeley packet filtering. So maybe I will give you some details on where you can refer what is eBPF. eBPF itself is a huge concept in Linux networking. So maybe if you can go through them, and what is sandbox program? Sandbox code. Just imagine like your application will run inside a program, the sandbox program. If it is compromised, it will not reach the OS. It adds more security. And why Cilium is using it? Because it also provides observability. That program level information, we can visualize it. So that is one of the driving factors of using Cilium, because Cilium is running eBPF. There are other tools also using eBPF, like Falco is one such tool. They are also into security, right? So security means they have to visualize what is running inside your application. So what is compromised? If there is a compromise, will it affect the other application? Will it affect the OS level details to be attacked? No, right? So that's why eBPF is getting widely popular, and then it's adapted by tools. So Cilium is using eBPF concept. So why we are not, Calico is using BGP, and then Cilium is using eBPF. Now they are bringing in, but Cilium is out from when it was launched, it was using eBPF, and that's why it was getting popular among other CNIs. And also our Kube Proxy. So whatever we had in the native, whenever you create a cluster, it has a KindNest or KubeNet, everything. So it does not have L7 layer capability. So you cannot debug too much what's happening at the application level. So the Cilium is application aware. So I'm going to show a demo on that now. And then it also supports all these type of policies. So I will also give you a demo on what is policy and what policy you are using, how you can restrict the access between applications using the policies. Okay, network policy, Cilium network policies. And those policies we are going to restrict at the HTTP level, at the DNS level, at gRPC level. All these are protocols that are that can be restricted for your application. So only HTTP calls are allowed, means you cannot access DNS calls there. So that minute level of restrictions we can provide with Cilium. So don't take too much for now. Just understand it is providing these capabilities like DNS, HTTP protocol level capabilities, and it is application aware, wherein whatever Kube Proxy knows, it only knows the IPs. So each and every IPs will be updated in the Kube Proxy. For each and every service, it will be updated. But wherein in Cilium, it's identity based. I'll show you what is identity based, and then let's dig more into it. So for some of you asked what is the features and why we are choosing Cilium. So I'm going to show. So we are going to see, instead of IP tables, Cilium uses EBPF, and the performance with IP table is lower when your cluster is growing. For example, I said about 100 nodes of clusters. So then how long it will take? Then you will see a visually lag in routing. So there, for a fraction amount of time, you will see the drop in your application. And sometimes people will get errors when they are accessing. So that type of performance latency, bandwidth issues will be there. But when it comes to Cilium, it is faster. And observability, so we have seen the observability that comes out of box with Kube Proxy, right? We have to log in, and then you have to take a TCP dump and then visualize what traffic is sent at what time, and then too much of debugging. So we don't have any visualizing tool. So Cilium has inbuilt tool called Hubble, so which will give you which traffic is sent, from where the traffic has started and where it reached. So from where it is allowed and from where it is dropped. So that much of minute detail Cilium provides. And of course, at the security level, without Cilium, it's L3 and L4 level of application routing. But when it comes to Cilium, it works from L3 to L7. So L3 means IP, L4 means port, and then L7 means your application aware routing. So these are the majorly they will use L3, L4 everywhere. When you read about it, they will say L3 layer support, L4 layer support. So Nginx means L3 layer support, they will say. Istio means they will provide L7 layer support. So that means so it only understand L3 means IP, L4 means IP plus port, L7 means it knows the application as well, like path-based routing, everything will come into L7. And scalability is again very high with respect to Cilium. It's all based on, it's controlled by your Cilium operator. Yes, Ganesh.
So this L3, L4 are related to the network level layers.
Yes, it is the OS layers.
OS,
Yeah, it was a network level layering concept.
OSI or TCP?
Yes.
So ma'am, actually L3 is the like network layer, okay, and L4 is the transport layer, okay. Like as I know, like we use the L4, like if we are using the some live streaming application, so we use the L4 load balancer. Like there are multiple type of load balancer, right? Like application load balancer and the network load balancer. So application load balancer work on the L7, and network load balancer work on the L4. So in the like without Selenium, we haven't using the L7, and with the Selenium we use the L3 and the L7. So so why there is not the transport layer like L4? Like this is quite confusing.
Okay, it's not from L3 and L7. It's L3, L4, until L7 it provides.
Okay.
So
And
it's not
without Selenium,
L7,
it is not provide the
L3
application
and
layer.
L7, L3 to L7. So it provides from L3 is a network, right? The IPs. L4 is your transport layer. L5 is session. L6 is presentation. L7 is your application. So it provides all from starting from L3 to L7, application aware. So basically, it provides application aware. That's what we say, right? So it provides application aware means, of course, it provides L3 and L4.
Okay.
Okay, shall we move on to the lab? I think we are already over time for today. Let's see if I can finish up the Cilium and then we can wind up. So this time I'm going to use Minikube. If you have Minikube CLI, you can use. Otherwise, you can use kind CLI to spin up the cluster. Just for to showing different CLI, I'm spinning up it. Okay. So if you don't have Minikube CLI, try to install it, because it is we can make use of other tools to spin up the cluster. If that's not working, then you can check in maybe you can check in ChatGPT what's the equivalent to spin up the kind cluster. Then you can create it. And I also want you to install the Cilium CNI parallelly. Okay. So you will find the CLI installation step here. Just install the Cilium CNI, because we are going to install Cilium onto our kind cluster, onto your local cluster, kind or Minikube. So my cluster is still getting up. I have the cluster. Anybody able to spin up the cluster?
Yes.
Okay. So install the Cilium CLI.
Sure.
Sorry, I'm not doing any hands-on today, Lavanya, but you will share the README file, right? Example with the commands and all those things.
Yes, it is already shared. You should be having access to this. Like
Okay.
I have sent that
Okay.
in our chat before starting our session. I have sent the GitHub link, so you can make use of it. So I'm not doing anything out of it. I'm just copying from here and then doing the lab. Okay, so you should be able to run the lab without a me. Okay. So I have installed Cilium CNI. So we are going to install Cilium with Cilium CLI. So there are other ways to install it. So we have a Helm chart to install Cilium CNI. Yeah. So for now, we are going to use Cilium CLI to install. So just run Cilium install. It will run and install all the Cilium operator. Okay. So for you guys, it should install Cilium by default. It's giving me problem. I'm going to fix them. So meantime, you can run Cilium install and then start. Yeah, you can go through the next step as well if you are interested, or else wait for me.
I'm just installing in the current kind cluster only. I'm not spinning up new cluster.
That's fine. That's
Yeah.
fine. So it should take some time to spin up all the Cilium pods. So meantime, let it start. I would also give you a little bit of background about the Cilium architecture. Okay, so yeah, onto the screen. So we are using Cilium CLI to install the Cilium for now. Okay, and then what it will install? It will install these components. So Cilium agent is one of the components that's primarily doing your CNI works. Cilium agent is the master. You can think of something like that. So all your related routings, everything will be taken care by your Cilium agent. And Cilium operator is the one that connects to your API server. Okay. And then there is a pod called Hubble Relay. You will see when you install Cilium, that is going to be your UI. So it is going to give you the details about the packet transferred, packet flow, traffic flow, everything will be your in your UI. So the UI is Hubble, and then Cilium agent is the one that connects to your eBPF kernels, connects to your kernel namespaces, and then performs the sandbox based execution there. Okay. So, but your pod, this is the pod networking, right? So it will connect to your network, the kernel networking through your eBPF program. So everything is now replaced with eBPF concept. So
Ma'am, is exactly eBPF? Like what it does, why it exists?
sure, I can give you some details about it now, but
Sure.
I will urge you to read about the eBPF itself. Again, just go back and then have your own visualization of what is eBPF. So for now, I will try to give you. So it is called eBPF. The expansion is extended Berkeley packet filtering. So that's not the concept that is coming with the Cilium. So it was there in the kernel networking itself. So it's the Linux networking that allows you to safely run your programs inside the kernel. So if you see here, inside the kernel, you have to run your application, right? So that is taken care by this eBPF. So it's widely used for networking. Network between Linux networking, and then basically it provides security and observability. How observability is achieved in Cilium, it is achieved using Hubble UI. Okay, so basically it has improved performance as well. Okay, so just consider you are running the program inside the kernel with the eBPF concept. Okay, basically you are, so this is the box, right? So you are running all your programs inside this eBPF box, not directly by making a system call to the kernel modules. Okay, so maybe I'll give you more details, better document, then you can get to understand your own version of what is eBPF. So traditionally it was using IP tables, now it is used by eBPF. So network packets, system calls, all these events will be handled inside this queue eBPF. Instead of making direct system call, everything is done through eBPF. So network packet, system call, file access, and process creation, everything is done through your eBPF. So that is what it does. For example, during your traffic flow, a packet arrives, eBPF is the one that runs first. When you have Cilium, the eBPF is the one that runs first, and then if you have defined any allow or block policy, then it will block the traffic to that application, and then your application will be served. Otherwise, by default, what is your traffic flow? So first it comes from client to load balancer. So let me pull up this diagram again. So from client to load balancer to service, here what it has IP tables, right? IP tables, and then it has a lot of rules. But instead of IP tables, it just has eBPF, and eBPF does not have these many chains of rules. All it does have is very not all the pod IPs are mapped. It's just the application, each and every deployment will have its identity, and using that identity only your routing will be happening, not using the IP. So main difference between IP table is it is using the IP, but when it comes to Cilium, it uses the eBPF, and the eBPF how the pod routing is happening, it is happening using your identity, pod identity. Each and every deployment will have identity. So maybe I'll show you where when the demo is. And install Cilium. So let me install Cilium. So you will see Cilium operator is the one that is doing all our API call interaction. Cilium envoy is the Cilium agent that runs on all your nodes, and then it does all your traffic routing. So let me pull up the diagram again. So Cilium agent that runs on your node, and then it performs all your routing. And then I was saying about eBPF. So maybe in the next session, I would ask what is eBPF. Just be ready to give your own version of it. So what sandbox programs and how the traffic routes. So what is the difference between the traffic routing with IP table, and what's the difference with the eBPF? What is the advantage one over the other? So I'm going to raise that question. I will give you the answer. But yeah, prepare yourself, because whatever I say, it's too much for you guys now, right? So better we'll park it for next class. Okay, let me see. All pods are still spinning up. Anyone? Did anyone install Cilium? That's all the pods are up?
Yeah, all the pods.
Okay. Maybe you can share your machine and we can see how it is. Yeah. If you don't mind, you can share that.
Yeah, is my screen visible?
Yes.
Okay.
So Cilium envoy, you have two node cluster, right?
Yeah.
Okay. So Cilium envoy is a daemon set that runs on all the nodes to route the traffic. So do one thing. Now you install Cilium and just check the Cilium status command. So you will see, so instead of checking the pods, you can see it here as well. So whether Cilium is running okay, operator is up, envoy is working, and then how many number of replicas, and then if there are any problem, it would have shown you in red box. So for me, yeah, for me also it is still, it's running. For those of you, it's still in spinning up state, you will see errors here. Okay. And what is the image that is used for Cilium? So all these details, you will get it from here. So always all these, the Cilium should be up and running. Otherwise, you will experience some network issues in your cluster. Routing problems for some application, it will work for some, for not for some. So it's based on all the Cilium agents running across all nodes. So all should be up always. Okay. So this is one such thing you can debug when there is a issue. And can you also enable Hubble? So that's the next command. Hubble, Cilium Hubble enable UI. So now check the Cilium status. So just check the pod status. Until that time, it will be in error state. So you will see two pods coming up. One is relay and UI. So relay is the one that is doing your monitoring stuff, and UI pod is going to give you an UI. So now, so you it will you have the facility to now port forward and then check. So it's still not up, right?
Yeah, still not. Yeah, it is up.
It is up, right? Okay.
Yeah.
Now you check the Cilium status, it should be green. And then do a port forward. So port forward is nothing but either you have a application URL configured in your Nginx, or if you don't have, for now we don't have any Nginx running, right? So that's why we are using port forward every time to access the application. So it's just the local way of accessing your application. So within cluster, we don't have any external tool, just that you do the port forward and access your application.
Okay.
So you can also do the port forward if all your pods are up.
Yeah, port forwarding Hubble relay. Is it?
Command I have already shared in the PS4. You don't have to do anything new. Yeah.
Shared in GitHub or
GitHub. Okay, I rejoined. Maybe okay. I'll share it again.
Okay.
Yeah, this is where, right. So just search as Hubble. Next, Kubelet exposed. No. On the same line. I think it Kubelet. Maybe I'll give you the command. It's there after Hubble UI enable. No, I'm sharing it in the chat. Just pick it from there. Yes, that's right. Kubelet namespace cube. Yeah, I think some alignment issue. I can fix them. No worries.
yeah. Oh.
Yeah, now access that endpoint. 121.0. 12,000 is the Hubble code.
Should be accessible on
You don't have a service called Hubble UI?
no. I have Hubble relay.
Okay, can you check, can you enable it again? -UI? Hubble command. Yeah, Hubble -UI. Just check your pods are getting up. So yeah, UI was not enabled. That's why we are not seeing that service. Okay. So Hubble was only enabled, UI was not enabled. So now the command which I gave should work. The
Yeah.
pods are.
Yeah.
So this is the Hubble UI. So choose the namespace. Which namespace? Just check Kube system. So you will see what are all the pods and how it is routed. So whether you have a allow or deny. Okay. So now you spin up another WSL console and create a new deployment. So just to go back to the document and then run. So I want to do everything from your side rather than my side to see if it's really working, so that if anybody were not able to follow, they can go ahead and then fix all their issues, then try to run this lab themselves. So yes, that's the command. Let me try to fix the formatting issue, but you got the idea, right, what we are doing.
Yeah.
So
Just
Kube,
open the code so you will get the like a clear view.
yeah, maybe you can visualize it not as an MD, just as a
Code.
code. Instead of preview, just to, that's better. Thank you. Yeah, I'm not used to this screen sharing. Yeah, sharing. So no, you'll have to have the port forwarding.
Okay.
So bring up another console. So otherwise you will not see the Hubble. Okay.
Yeah.
So first to create the namespace. So far we were doing in default namespace. Okay. Now we are going into the Kubernetes namespace that we discussed today. So we have created a namespace and we are doing an Nginx deployment within that namespace with 4 replicas. So yeah. So now expose this application to go run the other one. So we are creating the service. First one we create deployment. Second one expose is the command to create service. Yep. With just deployment we can't do anything. So we have to have service. So these are the, so whenever you run any application, you need to have minimum these 2 files. So we need to have much more like ingress and all, but these are the 2 things that we need for to run any application. Okay. So now create another backend deployment in the namespace table. Yeah. So we are creating another deployment called front end. So what we are trying to do, we are going to block the traffic between these 2 applications. That's what we are going to do.
I think here also we need to. Okay.
Okay. Yeah. I'll make the change right away.
Do we continue creating these labels?
Yes, create the label. So now we have created 2 deployments, 2 applications basically. So these 2 applications are there in the same namespace. So now we are labeling these 2 applications as front end and back end. So if we are doing it YAML, we can do all this at one step, but now we are using just imperative commands. So that's why I want everyone to see what are all the commands that we can use, like labels, expose, get, describe, logs. So these are the basic commands that we use in day-to-day operations. So now we have all the pods running. Okay, good. So you also labeled it, both front end and back end, you labeled it.
Yeah, I'm labeling.
The labeling is important. Okay, based on this label only, the identity will be assigned in Cilium. So you should have some label. So based on the labels only, it will have identity. So yeah. now what you do, you exec into one of the front end. So now we are sending traffic to backend. So we are testing the connectivity. For one, run one by one. Yeah.
Okay. We are in front end pod.
We are in front end pod and trying to hit the backend. So what do you think? Yeah, curl, loading curl. We should have traffic. We didn't enable any restriction between these two pods, right?
Yeah.
So both are running in same namespace and both are accessible. Front end can access backend. So if you visualize it, so you have front end application, back end application. Front end is accessing your backend. So this is not the right example, but just visualize like we are going to restrict access between two applications. So how that is being done? It will be done using network policy. So you, yeah. Can you check? Go to the Hubble UI. And filter the namespace to demo. So we are in Kube system. So now the traffic is forwarded from front end to back end. Okay. But suppose if we want to restrict this, so how it will be done? It has to be done using network policy. So Cilium provides network policy feature capability. So we are going to make use of it to restrict these traffic flow between these two applications. So the same can be achieved across the namespace as well, but we are going to try using the same namespace. Yeah. So now go back to the document. So now traffic forwarded, we are seeing, right? So do one thing. Okay. Can you go back to the GitHub repo?
No, this is the
Okay. Week two, and something called network policy, deny policy. Click on that deny policy.
deny. Okay.
Deny policy. Yeah, this one. Yes.
Okay.
Can you apply this YAML? kubectl apply -f. So if you are navigated to, maybe you can pull up another screen.
-if.
Yeah.
Did it create?
Yeah.
Okay, now do the call again. So you are sending traffic to the same backend pod now. Not this one. Called HTTP Nginx backend, not http.com. So maybe you can refer the document now. CS code again. Yeah, that's fine. Yeah, that's the one. So what did we do? We did create a deny policy from front end to back end, and then we are inside the front end pod trying to hit the back end. So now you are not getting the previous response, right?
Yeah.
So otherwise you should have got the Nginx page. So just to go back to the Hubble. So this is what happening from the application side. So how do you visualize it? You will make use of Cilium feature, which is Hubble UI. Just go back to your Hubble UI and then refresh the page. Can you check the port forwarding is working? And also your applications are running.
Yeah, this is working.
Lavanya,
Yes,
how much topic is like left for today's class?
that's it. I think we'll complete in maybe 5 minutes because I'm just, I want to just see the denied traffic. That's it. All your call running. Can you hit again? Just can you call it again?
Lavanya, sorry to interrupt. I actually joined in between the session. When is it possible to share the recording? Maybe today evening or a bit later?
Yes, after this session itself, I can ask Shubham to share.
Thanks. Thanks a lot.
I think something wrong with the policy. Do one thing. I will share the policy again.
Okay.
Or you can do one thing. You can deploy a deny policy yourself and we should see the change. Whether in the Hubble UI, what you should see, you are seeing a green color button now, right? So ideally, you will see a red box and the traffic is dropped. Just click on any verdict there. If it's because of or let me check the YAML meantime. Just have a look.
When I do curl, it is not able to resolve actually. But
Let me check the policy once.
okay.
Let me try it in my machine. Let's see. Can we continue to finish this up, or I think we are already over time, or should we resume it? What do you think, guys? Can we finish this?
Yeah, should be fine.
Okay. So let me create the deployments. Just give me a minute. Think of what's happening. Just exit from the container and then relog in and then check again.
Okay. Yes.
What is the use?
No network policies are found.
Yes, did someone say something? So let me share my screen and show you. Okay, is my screen visible?
Yes,
Can you retry it again by port forwarding everything, Swarna? Because what I did the same. So you see all the pods were in spinning up state, and then I tried to connect to the front end. Then I did a curl. Then it launched me the Nginx page, and then I went ahead. So this is my Hubble port forward, and then if you see here, I created a Cilium network policy. So maybe you reapply it again. Something wrong with this. So because if I see the Cilium network policy, I should see the policy in the demo namespace.
Okay.
Space demo, and then check this YAML. So it is locking the egress. Okay. So now I did send a request to the backend after applying the policy. I did not got the response. So until here it was working for you. Just check by port forwarding again the Hubble UI. So now I am going to pick up the Hubble UI and I am into the demo or namespace. So if I visualize it, so I have created a backend like Nginx backend. So my traffic is blocked. I did not mention anything about the Kube DNS, right? I did not mention anything for this. So by default, that traffic will also be blocked. So you should allow traffic to Kube DNS to make your application up and running. So that's why it is not resolving, because it does not reach the Kube DNS at all. Okay, so that's why I'm seeing a packet drop. So to resolve this issue, what you have to do, you have to allow the Kube DNS destination as well. So then only it will work. So I will tell you more in the next class how to do this. Maybe we'll take some 15 or 20 minutes to continue this, and then we'll see. I'll give you more details on where to check. There are a lot of different types of network policies. So we'll dig deep before starting to the next session, maybe tomorrow, and then see. So for now, you see this traffic is dropped, and then you are visualizing in Hubble UI. So this is, so it will also show you whether it's an egress traffic or ingress traffic. So why it is denied? because of the network policy, and it is an egress traffic. So it is what event it is sending. It's sending to an endpoint, and source pod is from a front end pod. So each and every deployment will have an identity. So that's how Cilium works. So it's not based on the IP. So in the Kube Proxy, what we have seen, the source is a pod, but destination is the lot of IPs that we have seen. But this is sending based on the identity. So each and every application will have its own identity, and then based on that identity, send the traffic. So source label. So what are the labels, and what is the source IP, and then what is the destination pod and destination's identity. So this is the source identity, and this is the destination identity. So imagine it just updates one single identity instead of updating all 5 IPs. So that's why it is becoming very easy and very fast in terms of performance. And of course, Hubble UI, we can visualize the traffic. So if it is in IP tables, we saw the complexity of visualizing it, right? And then what is the protocol that we have seen? So we have seen it supports TCP, UDP, and gRPC connections, right? So what type of protocol also, it will show it in the Hubble UI. Yeah. I think with that, we can wind up today's class. Yeah. I think we have covered, yeah. I wanted to cover ATCD, so maybe we can resume it tomorrow. Any questions, team? Or how was the class? Just take a feedback from here, and then maybe we could improve it from the next session.
The class was good, Lavanya. Now, please share the PowerPoint. That
Okay, you
file
don't have access, right?
Yeah, I don't have access.
So
Yeah,
let me
and
do
also
that.
the assignments for today's session also, please post that in the group.
Yes, I will do that. And also you will see an assignment in the middle as well, so that we can prepare for the next session, because it is taking a lot of time. So I planned for 1.5 hours only, but it is taking more than 3 hours. So yeah, let's see. I would want you to run through all the assignments before coming to the next session, so that we make use of it, because we are covering more than 10 tools. So each tool 1 week, still it is not enough. So should make use of your time. So yeah, I'll assign the labs, not only one lab for 1 week, maybe multiple.
Your voice is breaking, Lavanya.
Hello. Yes.
Lavanya, your voice is breaking.
Yeah, I think we are all hoping that I find that.
When the class will conduct, like once in a week, or like in the week there is a 2 classes?
I think 2 classes, Saturday, Sunday.
Okay, so tomorrow will also conduct, right? Okay, thanks.
Yeah, thank you.
Yeah, bye everyone.